Measurement of absorption. When the light is absorbed by the solution, how it is measured, that actually depend on the Beer-Lamberts law. We are discussing spectroscopy, and actually it is the interaction of light and the matter, or the electromagnetic radiation and matter. That's why we have to discuss what happens when the matter is irradiated with light, and when the light is absorbed, that is having what is relationship is there. So that actually decided by the Beer-Lambert law. Now this law, first of all, this law is applicable to very dilute solution. That solution should be homogeneous and that solution should be transparent. So if these three conditions are satisfied, then only we can apply the Beer-Lamberts law. What is that law? I have given here in very short form that the proportion of light absorbed, how much light is absorbed, is depend upon the concentration of the solution and the thickness of the cell. So this is the statement of Beer-Lambert law. It indicates that the light is absorbed light is directly proportional to the concentration. Very simple. Now when we express this statement by using mathematics, that becomes log of I0 upon I equals to epsilon CL. Log of I0 is what? Intensity of incident light, and I is the intensity of transmitted light. Some light is transmitted. So this ratio, and epsilon, this is what? In a molar extinction coefficient. C is the concentration and L is the thickness of the absorbing medium. So log of I0 upon I is nothing but the optical density. This optical density A. So the optical density is equal to epsilon CL. It is depend upon the concentration and the length of the absorbing medium. So this is what? Nothing but the Beer-Lambert law. Thank you. Absorption spectrum. In previous video we have seen what is optical density and what is absorption. Now see, here in this video we are discussing the nature of the absorption spectrum. For the absorption spectrum we use a double beam spectrophotometer, where the beam or the light is divided into two beams. One beam is passing through the solution and another beam is passing through the solvent. So the absorption by the solvent is automatically cancelled, and the net absorption is actually by the compound which is under scan. Now that is done by the recorder automatically. Here if you look at the nature of the spectrum, absorption spectrum, here on this axis OD, optical density, is given, and on this axis different wavelengths are given. Now you can see here the maximum absorption occurs here in this spectrum. So the region where the absorption is maximum, this is called absorption band. So this is absorption band, and the wavelength at which this absorption band is appear, this is called lambda max, and the molar extinction coefficient at the lambda max is called E max. You remember all these terms. So this is how maximum absorption by the compound is obtained by using this absorption spectrum. Thank you.